All right, last video on 11.4. Let's go through functional groups, right? So in the last video, I ended off with talking about functional groups, what they are. Or you can have a halide functional group, you can have an alcohol functional group, you can have an ether, carboxylic acid, a ketone, or an ester functional group, right? And these are all things, as I was mentioning, that are kind of like adornments, things that you can stick on to our hydrocarbons and to make them look different, right? And so, for example, here we have 1, 2, 3, we have a propane, and on it we stuck on the functional group. It's a halide, specifically it's a chloro group, a chlorine group, right? And so here we have a 1, 2, 3, 4, 5 chain carbon hydrocarbon, right? So this is a pentane hydrocarbon, and then we're sticking onto it an alcohol functional group. Here we have a methane group, and here we have on an ethane group, and we are having the ether kind of split them up, and so it's kind of modifying them in that sense, right? Again, here we have a we actually have a propane group here, and then we're sticking on, sorry, I should circle this one. Right, here we're sticking on a carboxylic acid. Of course, this carboxylic acid also has a carbon, and so this really becomes a butane group, and then we have that carboxylic acid attached on. Here, this one was a little bit different, but I mean, it's the same thing. Technically, I could have a chain here. Here, though, we just had a hydrogen stuck onto a carbonyl group. So the carbonyl group is being added on, and so now we have So we have a ketone, a carbonyl group stuck onto it, and in this one, it was actually just a hydrogen, and this is what we call formaldehyde. I chose this one because it's kind of an interesting one that you guys know of. Formaldehyde is the thing that knocks people out. If you've seen like James Bond's movies where they, stick a napkin onto someone's face and they knock out, yeah, that's formaldehyde. And so it's kind of more interesting, but it's just hydrogen attached onto it. But yeah, you can put chains on. That's the point. Or sorry, you have a chain and then you can stick on a carbonyl. Either way, right? It depends on your perspective. You could think of this as like, oh, we're sticking on a chain onto this, or you could think of it as like, hey, I have a chain, I'm sticking on a carbonyl. All right, esters, again, right? Same thing. We're gonna stick this guy onto some sort of chain. And so here we have this 1, 2, so we have an ethane group, and then we're sticking on this ester onto it. And so, yeah, functional groups, we're sticking them onto our hydrocarbon chains. And so here, let's take a look at this guy. So we're starting off here with C5H11OH, right? And so draw out that 1, 2, 3, 4, 5, right, because that's that. Now, if you wanted to, you could have drawn it out. There is some level at which I know that it's going to look like this because, well, I think, I'm like, oh, that's 5 times 2 plus 2 is equal to 12, which is almost what we have here. Basically, what happened is we took one of them off. And so I'm already seeing that in my mind. But if you don't, you can draw it out. And you'll see, surprise, surprise, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 hydrogens with 5 carbons. And we have one more thing here. That's the hydrogen I was telling you that we took off. And instead, we're going to put on the OH group. So it's going to look like that. So with the bond line drawing, it looks like that. This is 1, 2, 3, 4, 5, and then we're adding on the OH. And so this is pentane, and we added on an OH, and so that's an alcohol. Now, we actually don't call it pentane alcohol. We actually we change it to pentyl alcohol. So whenever we have this as kind of like a chain that's being, we're attaching something else to it, we don't call it pentane, we call it a pentyl group. Now, do not get that confused. This is not pentane, pentyne. This is not pentyne, this is pentyl, okay? TYL. And so we're adding on a pentyl group, and to that we're adding on an OH, and this is the alcohol part. So yeah, pentyl alcohol. We also call it pentanol. That's kind of the more colloquial name for it. So yeah, there you go. Now, I will say on these two, actually, I have a typo. This should be 7. We went over this in class, but those should be 7. And so if we were to draw that out, we're going to have 1, 2, 3, 4, 5, 6, 7. So we have this propane group, and then what we're going to add on to it is the COOH, which maybe wondering what the heck is that. Well, go back to your list, right? The COOH, that's a carboxylic acid. And so that looks like this. So we're going to draw it out. Oops, sorry. We're going to draw it out here, COOH. And so there you go. Now, what does this look like in terms of bond line drawing? Well, we have 1, 2, 3, now 4 carbons. So we're going to put 1, 2, 3, 4 carbons. That carbon is attached to an oxygen and then an OH. And so it looks like that. Now, you might be tempted to call this bute, but it's actually now, oh, sorry, you might be tempted to call it prop because it was like, oh, we started off with 3 carbons. But remember, we added on this carbon, so it's not prop, but instead it's bute. Now, what's this? This is a carboxylic acid. And so we're going to use this naming convention. We're going to call it butanoic acid. Butanoic acid. Because we have 4 C's, so it's bute. Now, do note, it turns out that this was the same thing as the example. But let's say, for example, if we had 5 C's, what would it be? If we had 5 C's, 5C carboxylic acid, that would become pentanoic acid. Okay, so there you go. Let's go on to the next one. Here we have C3H7Cl, so it's going to be the same thing here, right? C3H7. So we have a propyl group, and then what we're going to add on to it, simply put, is this chlorine. And so what does this look like in terms of a bond line drawing? Well, you got these 3, and then you're adding on a Cl. What do we call this guy? This is, as we mentioned, propyl. It's a propyl group, and you're adding on chlorine. And so this is, altogether, propyl chloride. There you go. All right, now we're going to draw butyl fluoride. And so I give you the name. Can you figure out these things? Well, butyl fluoride, bute, meth, eth, prop, bute, 4 C's. So here we're going to put, I always like to draw first before I give the formula. I think that's easier. So this is a butyl group. And then it says butyl fluoride, and so, right, that's just fluorine touched on to the end. And so there you go. That's what butyl fluoride would look like. What's its formula? Well, 1, 2, 3, 4, C4. 1, 2, 3, 4, 5, 6, 7, 8, 9, H9, F. There you go. All right, bond line drawing. Well, 1, 2, 3, 4 carbons attached onto 1 fluorine. There you go. All right. Continuing on, methyl bromide. This one is quite easy. Meth is 1 carbon. So we got this. And then bromine. Bromine is Br. So we're going to attach it on to this carbon. And that's it. A methyl group with a bromine. And what does the bond line drawing look like? Well, it's not much. It's just, we got this 1 carbon, and we attach on a bromine to it. That's it. All right, formula CH3Br. There we go. All right, methyl propane, aka 1-methyl propane. Do note that the reason why I'm putting 1-methyl is because here we're going to do 2-methyl. So let's just go one at a time, and you'll see how this builds. So, all right, methyl propane. So we have a methyl group, as we've been realizing, right? A methyl group is just going to be CH3. And then we're going to attach it onto a propane, which, right, is meth, eth, prop. So a 3 carbon chain. And so they're going to come together. And so that's what it's going to look like here. We're just going to put on this methyl group to this propane. And yeah, that's what we have. What would this look like in terms of bond line drawing? Well, we have 1, 2, 3, 4. 1, 2, 3, 4, and there you go. Now, what you might notice, especially once I tell you the formula, right? It's 1, 2, 3, 4 carbons, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. What you'll notice is this is just butane, is it not? Right? Meth, eth, prop, bute, 4 carbons. This is 4 times 2 plus 2 is 10. Yeah, this is literally butane, right? Why the heck do we call it then methyl propane? Well, that's another way to call it that, but do note the reason why I showed you guys this is because this is actually 1 methyl propane. What I did is, as we mentioned, we can number our carbons, right? So if this is carbon number 1, we attached on the methyl group onto the first carbon, right? The methyl group got attached onto the first carbon, but we could technically put that methyl group onto different carbons, right? Like what if we put it onto the second carbon on the propane chain? Well, that would look different, right? If I was to do that, if I was to slide this guy onto the second carbon, it would look like this. And all of a sudden, that actually is very different than butane. Butane is this continuous chain of 4 carbons. Here, we actually have it branching off, right? If it might be helpful to see it in the entire Lewis structure, right? Basically, it looks more like this, where, you know, we have this kind of branching out. It's branching out here. And so this is what we call a branched hydrocarbon. And that's why it's important to think of it like, oh, 2-methyl propane. We have the methyl group branching off of the main group, the propane group. The formula actually still is C4H10, as I covered in another video. Again, these are isomers. Now, they have, however, very different properties. Basically, because this looks like this, we can stack them on top of one another. So, you know, when they're together, they're stacked on top of one another. Whereas these guys are not really going to be able to stack onto each other. They can get close, but it's difficult to stack them. As a result of this, they have very different, what we call van der Waals forces, which are the same thing as London dispersion forces, which we've learned in this class. And so as a result, they have very different boiling points. And so this is actually very important. These are isomers of one another. They have the same formula, but they look very different, and as a result, they have very different properties. So, isomers, interesting. We can, if we use this naming convention like this, we can distinguish between them. All right, let's finish up with 2-pentanol. So the way this is going to look like is 1, 2, 3, 4, 5, and then we are going to put on the OH. Now, I actually messed up, right, because this is a 2-pentanol, right? And so actually, we need to think of it like, okay, 1, 2, 3, 4, 5, and so we're going to put on the OH group onto the second carbon. And so it would look more like that if you were to actually try to draw it all out. It would look like this. Now I'm putting it like way out there. You don't have to put it way out there. It's just I want you to be able to see what's going on. The formula is actually C5H11OH, which is just like the first one we started off with. Right? Remember, we started off with pentanol. Now I'm saying 2-pentanol, right? We've learned this idea of like numbering our chain and putting on the alcohol onto the numbered carbon. And so now 3-pentanol, what will 3-pentanol look like? We'll do the same thing, right? The formula will be exactly the same thing, right? These are all isomers of one another. They have the same formula, but they look different. 1, 2, 3, 4, 5. And so we're going to put this on the second, or on the third carbon. And so it looks like that. Not going to draw out the structure. I think you guys get the point, and you can do that at this point. All right, so let's finish up with cyclocarbons. Cyclo means circle, and so these aren't necessarily always going to be circles, but they are going to be things which are enclosed. And so cyclopropane is basically just, you have prop, so that means 3 carbons, and we're going to have them connected. And so these 3 carbons are all connected, and then you make sure they all have 4 bonds. 1, 2, 3, 4. There you go. 1, 2, 3. 1, 2, 3, 4. There you go. And so that's what cyclopropane looks like. Now, what does the bond line drawing look like? Well, it's just 1, 2, C3, replace those carbons, and there you go. All right, so what does that look like? Right, that's just a triangle, right, which makes sense. 3 C's, 3 vertices, it's a triangle, right? What's the formula here? Well, we're gonna have 3 carbons, and then 6 hydrogens, so C3H6. All right, going on to cyclobutane, right? Bute is 4 C's, and so it's gonna look like this. And so the formula here is C4H8, and the shape is gonna look like this. Right, it's gonna be a square because it's 4-sided. And so we're starting to see a pattern here, right? Here we just double up the number of carbons to get the number of hydrogens. And so what do you guys think is gonna be here? Pentane, cyclopentane, 5 carbons and 10 hydrogens. I'm not going to draw out the Lewis drawing. You could draw it out yourself if you'd like. You can also take a look at my key. But yeah, the line drawing is just going to look like that, right? And similarly, you can guess cyclohexane at this point, C6H12, and it's going to be a 6-sided figure. There you go. Now, we can actually also decorate these the cycloalkanes with functional groups. And so here we'll do cyclohexyl chloride, cyclohexyl 6 C's. And so it is going to look like this guy with a chlorine attached onto it. You can attach it onto any one of these ones because it's not specified. And so, sorry, that gets into the paper, right? So you can attach it onto any one of these because it's not specified. Now in this one though, it actually is specified, cyclohexyl 1-chloro 3-fluoride. And so we can make a cyclohexane, and then let's call this carbon number 1. You can start off at any one. You could have called this one 1, 2, 3, right? Like you could have started off at any one, but we'll start off here. And so then we'll put the chlorine onto that first carbon, and we'll put the fluorine on that third carbon. And there you go. Right, and again, you could draw the Lewis structures. I think you guys get the point. The formula here is going to be C6H11 because we removed a hydrogen and replaced it with a chlorine. Here it's going to be C6H10 because we removed 2 hydrogens and replaced it with a chlorine and then fluorine. And so that's its formula. And so there you go. Now, last thing I want to go over for you guys is this idea of aromatic hydrocarbons. These you'll see a lot, especially in AP biology, because these rings form up a lot of organic compounds, a lot of organic substances. And so basically, if you take a cyclohexane and do some stuff to it, you can create double bonds, alternating double bonds. Now, interesting thing here with this guy is, does it have resonance? And what we can see is that, well, you know, if we drew it here like this, but I could just as easily have drawn it like this. No, right? Like it's the same thing, right? And so in reality, what's happening, the electrons are actually going to be able to move around. They can move around, and they are delocalized and they're moving around everywhere. And so it looks like that. Another way that you'll oftentimes see it drawn is we just draw it as a circle on the inside. And so this is benzene. This is what it looks like. It's interesting because, yeah, these electrons are in resonance. They can move around. It looks like this. As a result, the electrons are just kind of looping around at all times. And the reason why this is important, as I mentioned, is it comes up in a lot of organic compounds. And they have good smells. So, for example, vanillin, which is where we get vanilla flavoring from, looks like this. And you know that just really sweet vanilla smell. It comes from this. Cinnamol alcohol, which is where we get a lot of cinnamon taste from, looks like this. And so we see for both of these, they have these the benzene rings, which contribute to that aroma, to that smell. And so interesting little compounds, which was the last thing I wanted to tell you guys before you guys go off and kill it in other science classes. So hopefully that helps. Don't beat yourself up if this is hard. It's meant to be hard. It's difficult. It just takes some practice. Do your practice problems. Ask any questions that you need, and you guys are going to do very well on this test.